In this example, we're going to look at an actual application to a polynomial equation. This specific equation, if you notice, has degree 2. By the way, equations with degree 2 are called quadratic equations, and they're going to be explained or studied in detail in a future chapter. On the right is the graph of this quadratic equation. That is also going to be studied in detail in the future. The graphs of quadratic equations are called parabolas. This is an upside down parabola. But you do not need to worry about that now. This chapter, we're just going to learn how to solve them. That's what you're doing, is solving these equations. The graph is just going to be used as a reference. So what do we have? We have a golf ball. It is hit upward with velocity of 256 feet per second, and its height h above the ground can be modeled by this equation. H of t equals negative 16t squared plus 256t, where t is in seconds. So first of all, just to get an idea of what this looks like, if you notice that the height h is the y. The height is the y. They changed the letter there. And by the way, if you look at our notation, that is h of t is the function notation of that. And our time is in seconds. And t is our horizontal. That didn't change. And our height is in feet. So let's just use the graph to get a sense of what's going on here. At the point 0, 0 right here, that means the height is 0, and the at 0 seconds, that meant that the golf ball started on the ground. 1 second later, it was about, I don't know, 250, and the height was 250 feet high. 2 seconds later, it was maybe 450, somewhere right there, and somewhere around 8 seconds, maybe a little bit less, the height was over 1,000 feet, and at that point, it started going downward, right? Started going downward until it hit the ground. Which leads us to our question. Use factoring to determine when the golf ball hit the ground. So first of all, I'm going to write down my equation. And by the way, you can call the h of t just h if you want. And we notice that we have two unknowns. We have h and we have t. And the question asks, when, use factoring to determine when, so to me that is the t, when is the time, the golf ball strikes the ground. And we just saw when the golf ball strikes the ground, the height, which is the h, is 0. So how we solve this, we just simply plug in 0 for the h. And we just learned in this section to solve equations that are not linear, that have exponents other than 1. The best way to do it is by factoring. So how do you factor that? Well, when you factor, the first thing you always want to do is look to see what is common. And since 16 times 16 is 256, I notice that 16 is a common factor here. When the first variable is negative, I personally always like to take out a negative. I think it makes it easier, but that is actually not necessary in this problem. I also noticed in the variables that the t is common. We have a t times t here and a t in the second term, so I'm just going to write a t, put a parentheses, keep that equal 0, and divide negative 16t into each equation. So negative 16 and negative 16 is 1, t into t squared is t, negative into a positive is negative, 16 into 256 we see is 16, and again t into t is 1. So that would be the equation. That leads us to two equations using the zero factor principle. We know that each factor should better be 0. And to solve the first equation, I'm going to divide both sides by negative 16 to get t equals 0. In the second equation, I'm going to add 16 to both sides to get t equals 16. And those are two answers. Well, the first answer we already talked about. That's when it initially started. So the second answer is our answer. And by the way, this is in seconds. And it says in 16 seconds, the ball strikes the ground. Which brings us to the second part. It says use the graph to show or to estimate when the ball strikes the ground. And if you do notice, if you look where it's right going down here, it's at the 16, and that is the same answer. So you can see here, 16, that's the when it strikes the ground, and that's the height is 0. That point is 16, 0. So it's when it strikes the ground. So that is how you do part B. So that is the answer. By the way, 16, 0 is the x-intercept. So what you do for part B is just look for the x, or the t in this case, intercepts of the line. Hope that helps.